Hey, it's Andrzej on Software. When you're doing test-driven development, there is an important technique called spiking, or making a spike. This technique is based on the fact that it's very hard to TDD a new feature when you are not sure how the feature is actually designed and what are the responsibilities of different classes here. So it's better to start with a spike, which is basically an experiment. You write the code in your code editor. You don't care about tests in this mode, in this spiking mode. You just try to make this feature work and add methods where needed, add new classes where needed. This code doesn't need to be pretty. And basically you want to get the result as quickly as possible, and you want to reveal the unknown things in this feature. So you may want to start with listing, creating a to-do or whatever, with listing the things that you are not sure about, you are not certain about. Then you make the spike and you get the feature to work. And then, this is an important part. First, you list all the responsibilities and all the important points from your spike, all the points which are somehow related to the code, like which classes needs to be changed, which new classes should be written, which new units may appear. And this list will be very useful because now the next step is to throw away the code that you wrote. And by throw away, I actually mean not exactly this. I mean, remove it from the master branch or from the branch that you're working on. I like to do git diff of my local changes before I do that, and I put the output of git diff to some file so that I can always reference the code that I was writing, so that if I ever get stuck, I can quickly look up and see, okay, that was this detail that needed to be handled this way. So the result of the spike is two things: a list of the needed code changes and a reference code that was written as part of the spike. But now you have a clean situation to start with. Now you can go in an order that you choose. You can go through the list of responsibilities, and now you can actually TDD it. So for each unit that needs to be changed, and remember, not every class is actually a unit. Sometimes a group of classes is a unit. So for all of the points from your list, you're now able to TDD it, and if you do it in the right order, you can write a test, write the implementation, refactor, commit, push. And thanks to that, you can deliver the feature in a nice TDD way, and everything is tested nicely. So that was like this is the classical TDD way with spikes. And this is important because many people confuse this. They think that everything should be TDD'd, so even the spike is TDD'd, and it's very difficult to start with TDD coding a code which is not clear what to do. Some people go with trying to TDD at the integration level because this is at least known. But what I found in practice is that this is like too high level, and then you end up under-tested at the lower levels. And based on the pyramid of tests, it's better to test as low as possible in good architectures, in good designs. There is also another way, which is quite recent, I would say, because we didn't have a good tooling for that. It's based on the mutation testing tools. Thanks to mutation testing, you can discover which parts are not tested. So if you think, but you need to be really certain, because that's might be very tempting, and you might be wrong sometimes. If you think that what your spike produced, the code that was produced, was more or less the right design, but maybe there are missing tests now, you may want to run mutant. Like in Ruby, it's called mutant. In Java, it's PyTest, I think. And I think most of the languages have some way of working mutation testing tools now. So you run the mutant, and mutant changes the code. Like it gets the name of the class or the name of the unit that it needs to be mutated. It runs tests, and whenever the test discovered that something wasn't covered with tests, then you know that you need to write a test. So after this kind of session with mutant, you will end up with all the code changes being tested. So the result should be similar as with your normal TDD session. It's a technique that I haven't yet incorporated fully. I do it sometimes, but I think I still prefer this way with spikes and removing the spike and then starting from scratch. Although this does require the discipline, especially on the part when you need to throw away. We are so emotionally connected to the code that we wrote that it's very hard for us to delete the code. It sounds like a waste of time. But with good TDD cycle time, with good techniques, with good skills of TDD, you're maybe losing some. Like if you know what to do with TDD, it's very very fast once you have the TDD skills. So I think it's better to like fight with yourself and throw away the code. And the trick with having this git diff being outputted to one file, which you can reference, at least gives you this feeling that, okay, I didn't throw it away fully. I can still access it. I can still recover it. So thanks for listening.